This video will show you everything you need to know to get started building applications that get data from FSUIPC. It assumes that you already have Flight Simulator, FSUIPC itself, and Visual Studio installed. First, we'll download all the resources that you will need. There are 4 project templates that you can use to create new FSUIPC applications in Visual Studio. Using one of these templates will give you an application in either WinForms or WPF that includes the FSUIPC client library itself, connection management code, and a basic timer to get data back in real time. We'll take a closer look at these in a few minutes. First, I will show you how to install them. The templates can be downloaded from the website. From the Download section, select Application Templates and then Download. The package contains templates for both C# and Visual Basic.NET. I'll create a new folder called FSUIPCClientDLL and save the zip file there. I will now unzip the file. To install the templates into Visual Studio, I will open my Documents folder. You'll see a folder called Visual Studio for each version that you have installed. To install the templates into a version of Visual Studio, copy the Templates folder from the unpacked zip file into the Visual Studio folder. Here I will install the templates into Visual Studio 2017. I'll drag the Templates folder onto the Visual Studio 2017 folder and hold down Ctrl to make a copy rather than move. The templates are now installed. We'll be using them later on in this tutorial. If you use one of the application templates, you do not need to install the NuGet package as it's already included. However, you should still view this section as upgrades to the DLL are also delivered by NuGet. Here I have a C# console application that I want to use with FSUIPC. To access the NuGet Package Manager, I'll right-click on the Solution node in the Solution Explorer. Then I'll select Manage NuGet Packages. The Package Manager window appears. Click over to the Browse tab and type in FSUIPC into the search box. The FSUIPClientDLL package will appear, showing whatever is the latest version. Usually, you only get offered stable versions. If you want to try beta versions, you must tick this box called Include Pre-Release. The right-hand pane shows me all the projects in my loaded solution. To install the DLL into a project, just tick the box. The version always defaults to the latest. Press Install and the DLL will be downloaded. And a reference has automatically been added to my project. You can use the NuGet Package Manager to upgrade to newer versions. When the package is installed, you will see it on the Installed tab. If there is a newer version of the DLL, there will be a button here allowing you to upgrade. The example applications are the main documentation for this library. They include examples for beginners and advanced users, and they demonstrate how to use the library and cover all of the features available. On the website, go to the Download section and select the C# project. Save it in a folder of your choice. Here I'm saving it in a folder called FSUIPCClientDLL in my Downloads folder. Go to the downloaded file and unzip it. Go into the unzipped folder and double-click the solution file to load it up. To see the examples working, you need to have FlightSim or WideClient.exe running on your computer. I have FSX Steam Edition loaded. Build and run the example application. You can use the left-hand menu to explore all the features of the library and see them in action. For example, here is a demo of getting back basic payload information such as the gross weight of the aircraft and the total payload weight. In the top right of each example is a link to the reference documentation. This will be a list of all classes relevant to the example. In this case, we just have payload services. Clicking on the link opens a browser, and I can see all the methods and properties for this class, along with descriptions about what each property holds. To see the code required to get the information that's being displayed on the form, take note of the code number in the example. In this case, it's PS001. Stop the project from running. In the Solution Explorer, find the relevant folder, in this case it's the payload folder, then find the example using the code number and open it. In the code behind the form is everything you need to know to get this information into your own application. There are extensive comments explaining everything, and at the top of each example is an overview. There are two more items that will help you create applications that use FSUIPC. The first is the FSUIPC offsets list. This can be found in your main FlightSim install folder. I'm using FSX Steam Edition, so I've opened the FSX folder in my Steam library. Under the Modules folder, go to the folder called FSUIPC Documentation. For FSUIPC versions 4 and 5, the document you need is called FSUIPC4 offsets status.pdf. If you are using FSUIPC3, then the document you need is called FSUIPC for programmers. I'll open it, and you can see it contains a list of all the data available. For each offset, it lists the offset address, the size of the data, and a description. The description will usually tell you how the data is stored in this offset. This is the main reference for offsets and tells you everything you need to know about how to use the data provided. I'll be demonstrating how to use this information in a few minutes. Next, we'll download a handy conversion chart. Go to the download section of the website and get the offsets type chart. I'll download this into my FSUIPClientDLL folder. When you declare an offset in .NET, you need to tell the DLL which data type to use. The chart tells you how to choose the .NET type from the information given in the FSUIPC offset list. In a later section, I'll show you how this process works by adding two offsets to a new FSUIPC application. But first, we'll start a new FSUIPC application using one of the templates we downloaded and installed earlier. From the Start page of Visual Studio, I'll create a new project. Under the C# node, you'll find FSUIPC. There are 4 templates to choose from. First, you need to decide if your application will be in WinForms or the newer but more advanced WPF framework. Then you can choose a connection style, manual or automatic. I'll show you both types of project using the more commonly used WinForms framework. I'll start by selecting the manual connection. I'll name my new application Manual Connect Demo. I now have a new WinForms application with a form. This form already has controls and code to handle the connection. At the moment, there are errors in the project because the FSUIPC library has not been downloaded and installed. To fix this, we just need to build the project. The NuGet package will automatically be downloaded and installed by Visual Studio. We now have no errors. I already have Flight Simulator running on this machine, so I'll run this project. With the manual style of connection, the user is given a button to connect. When I press it, the DLL makes a connection and reports it's connected to FSX Steam Edition. I can then disconnect. While the application is connected, you can see that the data is being collected in real time from the flight sim and is displayed on the form. If I start the plane moving, the airspeed readout increases. The tick box shows the current state of the master avionics switch. If I change it in the sim, it changes on the form. It also works the opposite way. If I change it on the form, it controls the switch in the simulator. If the connection is running and I unload the flight sim, the connection will be lost and a message will appear notifying the user. You can use this template application as a base on which to build your own application. You can also examine the code to see how this form works. I'll close this solution and we'll look at the automatic connection template. I'll make a new WinForms application, but this time with automatic connection. When I run this project, there is no connection button for the user to press. Instead, there is a timer looking for a connection every second. I'll now start Flight Sim. As you can see, it has found the connection and the data is now being read from the sim. When I unload FSX, it notifies the user that the connection has been lost. It then goes back to looking for a new connection. The WPF template applications have exactly the same functionality. I'm now going to add 2 new offsets to this new application and display the data on the form. This will demonstrate the process of discovering offsets, declaring them, and consuming the data. The first new piece of data we'll display on the form is the aircraft's vertical speed. I'll search the offset list for vertical speed. And we find this offset. The 2 most important bits of information here are the offset address and the size. We'll use these to help us declare this new offset in the code. I'll go back to the code and find the place where the offsets are declared. I'll add a new offset. Now we need to tell the DLL what .NET type should be used for this data in the offset. To help us work this out, we will consult the offset type chart that we downloaded earlier. This chart shows which .NET type to use depending on 2 things. First, the size of the offset, and second, what the offset list says about the data in the offset. We can see here that the vertical speed offset is 4 bytes long. There are two choices on the chart for 4-byte offsets. Which one you use depends on whether the documentation says it's a float or not. There is no mention of it being a float here, so we'll go with this line here. Looking along to the C# column, we can see that we either use a signed or unsigned int. The documentation says this is signed. This makes sense because the vertical speed can be positive for climbing and negative for descending. Sometimes the documentation will not tell you if it's signed or not. You need to use common sense. For example, the offset for a heading would be unsigned because there's no such thing as a negative heading. So we have now deduced that we need to declare the offset as a signed integer, which is just int in C#. I'll go back to the code and fill in the type, and then give the variable the name of vertical speed. We'll set the value of this variable to a new instance of an offset. We now need to pass the offset address into the constructor. The offset list tells us that this is 02C8. This is a hexadecimal number, so we'll need to tell the code that. This means prefixing the number with 0x. For some data types, you will also need to pass in the length or size of the offset. Looking at the offsets chart, we can see that for integers, we do not need to do this. This completes the offset declaration. We'll now see how to get the value from this offset and display it on the screen. First, I'll add a new text box to the form and call it txt vertical speed. I'll also add a label. I'll be displaying the vertical speed in feet per minute. Back in the code, I'll go to the timer tick method. This reads data from the simulator every 50 milliseconds. At the bottom of this method, we'll add our code to display the vertical speed. The offset list will tell us how the data is stored. For this offset, the speed is in meters per second multiplied by 256. To turn the value back into meters per second, we would need to divide the value in this offset by 256. However, I would like feet per minute. Pete has helpfully provided the conversion for that as well. I'll copy that to use in our code. Back in the code, I'm going to declare a variable to hold the converted value. I will call it vertical speed FPM for feet per minute. The type is set to double, as this will give us the best precision. I'll set this to be the value from the offset and then paste in the conversion formula. I will mark the literal numbers with a D to tell the compiler to treat them as double type literals, since we want the result to be a double. Although it's not necessary, I like to add a double cast to the value. This value is an int and needs to be converted to double. The compiler will do this automatically, but I like to add an explicit cast so that the code reflects what's actually happening. Now that we have the value in feet per minute, we can now display it. We'll set the text property of the text box we created earlier to our converted vertical speed variable. We will need to convert this to a string though, because it's currently a number. This string conversion also allows us to specify the formatting for the string. I just want to display the values to the nearest whole number. So I'll add a format string F0 to display 0 decimal places. We can now see this new offset in action. The next offset will be the tail number of the aircraft. I'll open up the offsets list and search for tail number. I've found offset 313C. We'll now add this to the offset declarations at the top of the file. I now need to tell the DLL what .NET type to use for this data. Looking at the offsets list, we can see this offset is 12 bytes long and holds a string. Looking at the types chart, we can find this entry that's for any size offsets specified as holding a string. Going to the C# column, we can see that we just use the native string type. Looking at the last column, we can also see that we need to specify the size of the offset when we declare it. So let's finish the declaration. We set the type as string and give it a name of tail number, and then set this to a new instance of the string offset. We now specify the offset address, which was 313C. And this time we need to specify the size of the offset. In this case it was 12 bytes. This completes the declaration. Now we'll create a new text box on the form so that we can display the information. Now in the timer tick event, I'll set the text of the new text box to the value of the offset. No conversion is needed for this one. Let's see it working. This completes the demonstration. The example application is the main documentation and learning tool for this library. In the basics section, it goes into more detail about reading and writing offsets, including using the offset grouping feature. It then goes on to cover more advanced concepts and all of the helper classes that make it much easier to use FSUIPC in .NET applications. If you need any help using the DLL, I answer questions in the support sub-forum for this library, which has kindly been provided by Pete Dozen. You'll find a link to the forum in the Help and Support section of the website.